Today we are going to do something slightly different, which is eccentric buckling. Now I will upload homework 2 tomorrow rather than saying tomorrow on May 22nd. Okay. And then on Avenue to Learn, I'll show you my Avenue to Learn on week 3. Okay. And I believe you can see this. I'm going to, if you could download the examples that I've been doing today. And I want you all to go and watch this link. Is how to use your calculator function for trial and error. Okay. It is important that you need to know how to use this function on your calculator for your term test or for any or this term test, the next one, and the final exam. Okay, so these are the important thing. Right, so today we are going to look into eccentric buckling. Okay, so let's, before go into eccentric buckling, I want to draw centric buckling first. Okay, we're going to sketch centric buckling. So in centric buckling, if we have a slender bar, okay, and if we have our centroid, the load are applied on the centroid, okay, are applied linear to the centroid. So this is our Py. Okay, so this is our Py. Okay, now I'm going to directly after that, we are going to draw a situation where we have eccentric buckling. So the same bar that we have, okay, and then we have the centroid, again, the geometric centroid. Now, P is applied a certain distance away from the centroid. Okay, and this distance is known as E. Okay, so if I'm going to call this point A and point B, point A and point B. Okay. So what we realized that at point A, right? This what we just have over here, right? This is also equal, right? This is also equal. So I'm going to again draw the same thing. Okay. This is also equal. Okay. This is also equal to EY. And we have a moment acting at point A, which is equal to P multiplied by E. Okay, I repeat again. We have a load P, right? And then we have a moment multiplied by E. So these cases that you see over here, they've just drawn, is before deformation induced by buckling. There's no deformation yet. Okay. Already there is no deformation, right? You could see that in eccentric buckling you have Py already. Okay. So now the next thing that I want to show you, right? So this is before deformation. So if we look at during deformations, okay. So again, I'm going to sketch eccentric buckling. I'm going to sketch eccentric buckling or eccentric buckling. Okay, eccentric buckling during deformation. Okay, so again, I'm going to have a green line. Okay, so this green line is again our centroid. Okay, this is again our centroid. Now, remember our load P, okay, our load P is still applied vertically. Okay. However, our deformation now, okay, so I'm going to draw, I'm going to sketch our deformation. Our deformation looks like this. Okay, so if I'm going to draw the solid out here, exaggerated, as you can see. Right? And at a certain point over here, right? What we have is we have a P to counter, and then we have over here a moment. Okay, so I'll call this point Q, right? We'll call this point Q. And you have a counter moment over here. This counter moment is equal, this counter moment at Q is equal to P Y max. Okay, so Y max is the distance from here to the point over here. This is your Y max. And it happened that Q occur at L or Q is at L over 2. Okay, so if I'm going to go back here, this entire length that we have is equal to L. Okay. Now, if we look at eccentric buckling, okay, if we look at eccentric buckling, which is this is a case, we already have a what? A moment already. Okay, a moment at point A already. So during deformation, okay, eccentric buckling, Okay, so if we look at eccentric buckling, during deformation, okay, so I'm going to sketch our centroid, geometric centroid again. Okay, so our geometric centroid is somewhere around here. Okay, somewhere around there. And then we have an offset P. Okay, we had an offset P, right? Right, we have an offset. Sorry, I'm not draw the offset. I'm going to draw when we have P. And then we have a moment at point A, which is going to P multiplied by E. Okay. So now I'm going to sketch the deformation pattern. Again, both ends are pinned, as you can see. Okay. So when I sketch the deformation pattern, right? So this is our deformation pattern. And we are going to pick a point, or again, this is our point Q, where Q is at L/2. Okay. So for this case, we again have a what? A Y max. Okay. So now the counter moment over here has to overcome. Okay. So the moment at point Q now has to overcome the moment due to the eccentric load, okay, applied by P, and plus by P multiplied by Y max. Okay. So you can see the difference now. Okay. The difference is this term over here. Okay, the difference is this term over here. Okay. Now, how will this term affect? Okay, how will this term affect our analysis? Okay. Now, before I go any further, I'm going to copy both. Okay. And I'm going to write out the formula that the two different loads or the two different buckling configuration uses. Okay. So let's look at centric buckling first. Okay, let's look at centric. In centric buckling, we know that PCR is equal to pi squared EI over LE squared. Okay. And then from here, we have to ensure, right? We have to ensure that if we have a factor of safety, this will be equal to P critical over P applied. Okay. And then we have to test that the stress critical, which is equal to P critical divided by area, has to be less than stress U, or sometimes stress allowable. Okay. Now in eccentric buckling, is very different. Okay, I repeat again, eccentric buckling is very different. The difference is this. So you will have maximum stress, and this will be equal to P over A, okay, bracket